All right, Integrated Math 3, this is a continuation of the 5.01 answers video. We're going to go on with number 9. We're going to skip number 10. We're going to do 11 and 12. So let's go ahead. So find the missing links. Leave your answer as radicals in the simplest form. That makes the problem a little bit different in radicals. It means if you have a square root of 2, they don't want you to go to a calculator and calculate what that is in decimal. They want you to leave it as square root of 2, or it could be a square root of 3. We'll see these as we do these types of problems. So this problem requires a little bit of knowledge of geometry from your past classes, which may have been forgotten by now, but let's go ahead and learn it. So one thing we know how to do is figure out what this unknown angle is. We know that this angle plus this angle plus this angle equals 180 degrees. So if I want to know what this angle is, we take 180. Okay, so 180 minus 90 degrees here, minus 45 degrees here. That gives us 45 degrees there. All right, so you have two 45-degree angles, and a principle of geometry says if these two angles are 45 degrees, if you draw like a dashed line, think of that as a mirror. This side is a mirror image of this side. So if this 45-degree angle produces a side that's 3 root 2, that length right there, then this 45-degree angle is going to produce the same thing over here. It's going to be 3 root 2. If you have the same angles, then the sides have to be the same length as well. All right, so now at this point then you can simply use the Pythagorean theorem to do this. There's the hypotenuse. So again, this is C in the Pythagorean theorem, the hypotenuse. It doesn't matter which side is A or B, so we'll just call this A and this B. So we go ahead and write that. All right, so that's going to be 3 root 2 squared, okay, equals this x squared. So how do you do this? It's simple. You just square both of these. So 3 squared is 9, and square root of 2 squared is 2. 9 times 2 is 18. So square root of 36 equals x, and that's going to be x equals 6. So this side over here is 6. And that's how you do that. Okay, I'm going to leave number 10 for lesson 5.02, so I think it fits in better with that lesson. So we're going to go on to 11 and 12. And these are two kind of real-world word problems. So one thing you do with these types of problems is draw a diagram to get an idea of what the words are saying. So it says from a point level on the ground, 80 feet from the base of a building, the angle of elevation is 25.6. Approximate the height of the building to the nearest foot. So we're going to come over here and just do a sketch of a building. You can draw windows if you want. You don't have to do that. But there you go. There's a building. And what it is saying is, I'm actually going to make myself a little space here. Okay, I'm going to put that right there. And it says that, okay, so you're 80 feet from the building. So there's 80 feet. And there you are right there. There's your head. And you're laying on the ground like that. And you're looking up at the top of this building. So I'm going to draw that from your eye level right there on the ground to the top of that building. Okay, so there it is. Get some of these extra lines out of here. Okay, so what you've done is you've created a triangle. And what you want to know is you want to know this height right here, that distance. An angle of elevation, so what is that? That means as you're looking, your eye level is right on the ground. You're looking here. That's 25.6 degrees. Okay, so at this point you can ignore the building. That's not important. You've got a triangle. And you have one side of the triangle and you have the angle. So label your sides. This is the long side. It's the hypotenuse. There's the angle you come across here. This is the opposite. I'll draw it on the inside since there's more space there. And this is what we want to know. You want to know what that opposite side is. And over here is the adjacent. I'll write that right there like that. That's the adjacent side right there. Okay, so what you're looking for is this opposite. What you know is the adjacent. So opposite, adjacent is going to be the relationship between tangent. So opposite over adjacent is tangent. So come over here and write your formula. So the tangent of theta equals okay, and now you plug in the numbers. So the tangent of that angle equals opposite over 80. So go to your calculator. You can pull up our online calculator and find out the tangent of 25.6. Okay, there we go. So we're going to go ahead up here and we're going to put in 25.6. Come down here and click on tangent right there, and it gives you 0.479. So I can write that over here, 0.479. Green here. Okay, so I wrote 0.479, opposite over 80. Now I'm going to move up here just so I have more space. Multiply both sides here by 80. Cancel, cancel. And it's 80 times 0.479 is going to be the answer. I'll just do that on my hand calculator, and that gives us 38.3. So the opposite, 38.3 what? 38.3 feet, because we're dealing with feet here. So this is 38.3 feet. That's the answer. That's the height of the building. Okay, all right. Let's do this last one here. This one's similar, but adds a little bit of a complication here. From the top of a lighthouse 160 feet high, the angle of depression of a boat out at sea is 24 degrees. Find to the nearest foot the distance from the boat to the lighthouse, and the foot of the lighthouse is at sea level. So again, we'll just draw ourselves a simplified little lighthouse here. Okay, and here's the sea. This is the ocean. So here's the boat out here. Okay, it's got a little sail on it. So there's a boat. All right, so we're going to say they're talking about right here at the base of the boat. So what you have is, what you're talking about, angle of depression. What does that mean? Well, first of all, you're talking from the top of the lighthouse to the bottom of the boat there. Okay, so you've created a triangle there. So the angle of depression, and I'm going to draw an entire rectangle here, and I'll show you why in just a second. Okay, so angle of depression is this. It means from a horizontal line to the angle that you're looking down at that boat. And they're saying that's 24 degrees. Okay, so there's two ways to do this. You could actually work with this triangle. That's one thing you could do. Another thing you can recognize is a principle that if this line is parallel to this line, this is a principle from geometry you've had in past math classes. If this line is parallel to this line, then this angle right here is equal to this angle. Those are called opposite interior angles. So that would be 24 degrees. Another way you could do this is if this line is horizontal and this line is perfectly vertical, then these two lines, if I took this line and this line, I know it's not exactly curved well, but those two lines would be 90 degrees total, just like this down here is 90 degrees. That would be 90. So if this is 24 and this is 90, then subtract 24 from 90, and this angle right here would be 66 degrees. That's just this angle right there. That's 66. That's a 6. 66 degrees. So you could figure out that if this is 90 and this is 66 here, this angle right here, then that's got to be 24 because they have to add up to 180. So anyway, what you come up with is this is 24 degrees. Okay, so what you're going to do then is you're trying to find out. You say it's the lighthouse is 160 feet high. I'm going to write that right here, 160 feet. That's this height right here. So what you want to know is what's this? What's this distance from the base of the lighthouse to the boat? So again, we're talking about this triangle right here. So this is the hypotenuse. Opposite this 24 angle is opposite. And right next to it here is adjacent. So what we're trying to find out is the adjacent, this, and we're given the opposite, this. So again, we need to have the relationship between opposite and adjacent, and we just did that on the last one. That's going to be this one right here. That's going to be tangent again. So we'll come over here and write the formula. Okay, now we can plug in the numbers. It's the tangent of this angle is 24. Okay, the opposite is 160. And our unknown here is the adjacent. Okay. All right. So go to your calculator. Just go to your online or your hand calculator. I'm just going to do it on my hand calculator. And I have tangent of 24 degrees gives us 0.445 equals 160 over adjacent. Okay. Now we have to solve for adjacent. So it's a two-step algebra problem here. You get rid of the 6 because that could be confusing. Okay, so we're going to multiply both sides by ADJ. That's our unknown. And over here, ADJ. These cancel. So I'll rewrite it down here. Okay. We divide both sides by this. That cancels. And you have ADJ equals 160 divided by 0.445. And that gives us 359. So that's the distance right here. So 359 feet. That's how far the base of the boat is from the base of the lighthouse right there. Okay? And that's all there is to those problems. So go ahead and get those done. This won't be due till next week, but you need to kind of have a grasp on this to do the next lesson. Okay? So we'll see you then.